So now moving on to the second video of this same section, domain and range of a function, we're now going to focus on 4 and 5. So one, you'll know what a relation is, and then you'll be able to determine if something is a function or not by performing a vertical line test or by interpreting the points that are given to you. All right, so we're now going to be given some scenarios that aren't functions, and you'll have to be able to identify that. And let's go ahead and get started in this video right away. So this way it could be a little bit shorter than the one that we just did. All right, so first off, the definition of a relation is it pairs inputs with outputs, and a relation that pairs each input with exactly one output is a function. All right, so when we talk about a relation, it's this pairing inputs with outputs. We can think about it being the equation that we're plugging things into, that we're substituting in our input, and then we're getting our output. So we're getting that x and y value, or we can just look at it as the graph where we're pairing our x and our y values. But same thing before is if our relation has exactly one input, or I'm sorry, if each input has exactly one output, then it is a function. All right, so now I'm gonna give you three different tables, and we're gonna talk about what makes one not a function versus what makes the other two a function, and how two of them seem very similar, but they're very different at the same time. All right, so I'm gonna give you a couple tables, and then we're gonna just do some examples of being able to determine if things are functions or not. All right, so here are three different tables that give us some x and some y values, and I'm kind of showing you different scenarios that can happen, and when some are still considered functions and others aren't. And you need to be able to identify why. All right, so when we look at the scenario A, this one should hopefully jump out that this is a function very easily because none of our values repeat for anything. We have for 5, we have -8 for y, we have 8, we have 6, 12, 1, and 22, 38. So nothing should really be confusing you with this because all of these x and y values are all different. Nothing repeats. And we know that in order for us to have a function, every single x value, so all of our inputs, just have to have one y value. And 5 has -8, 8 has 6, 12 has 1, and 22 is 38. So none of our x values repeat, and none of them give us two different y values. So that one should be nice and easy. But when we look at scenario B and scenario C, I see that I have two y values that repeat here. And I see here I have two x values that repeat here. But they're very, very, very different. All right, so when we're looking at the scenario B, even though we see y repeat twice, that's okay because when we're substituting in 6 for x, it only gave us one y in return. When we substituted 11, it only gave us 1. When we substituted 13, it only gave us 1 in return. And when we substituted 25, it only gave us 1 in return. Yes, two different x values can give us the same y. That's fine. All right, it doesn't say that y can never repeat, because if you think about that, when we had the equation y is equal to 5, well, our y value would repeat every single time for that, but that is still a function. All right, so it doesn't matter if our y value, if our two different x's can generate one y value. That doesn't matter. It's whether or not we get confused with our input. Because if we were thinking about a vending machine here, well, maybe their soda can is there's two different buttons for the soda can, so I can press D1 or D2. So regardless if I press D1 or D2, I'm getting Coke, but I'm pressing that specific button still only new to give me that Coke in return. Do you get what I'm saying with that? So when you guys are thinking about this, it's not that the y value can never repeat, because the y value can, as long as if it's through two different x's. Right, as long as if it's two different x's that are generating that. If it's just 6 gave me this -8, and then down here 6 also gave me a +9 or something, that's where we have some issues. All right, but we can substitute two different things in for x, and they can still give us the same y value. So this, even though it may appear to you, oh, that can't be a function because we have two different y values. No, we can get where two different x's give us the same y. Just like the soda machine I was just talking about. D1 and D2 can both give us Coke. All right, that is fine. But when we look over here, I see that when I plug in 9, it gave me -6 one time. And when I plugged in 9, the next time it gave me 4. Whoa, wait a minute. How does the machine know which one to give us? All right, when I plug in D1, it's not going to say, oh, well, is that going to give us chips or is that going to give us soda? No, it needs to know exactly. So this one is not a function because our X9 actually generated two different answers that we can have. All right, so we can have where two different x's give us the same y, but we cannot have where one x gives us two y's. The vending machine cannot be confused when you press D1 of what to give. All right, maybe we would love that the machine would be confused because when we press D1, it gives us everything. I mean, we would all love that. But in terms of a function, anything like that will cause a lot of issues, and it is not a function because we would get stuck on which one to use. All right, the machine would get confused and malfunction. All right, so this is, I just wanted to, before we get into going through graphs and other different things of determining whether things are a function or not, I just wanted to just point this out to you when we see a table, that just because we see numbers repeat doesn't mean it's not a function. We have to see, okay, let's think about the relationship. Let's think about the relation. Is it that the y is being generated from two different x's? That's still okay. Or is it that the x is generating two different y's, and that is not okay? All right, now let's move into one more thing before we go through just a few examples using graphs and other things. Okay, not only outside of a table will we have to determine something is if the graph is a function or not. We'll actually have to look at the graphs and determine. And one of the ways that we can determine that just by looking at the graph is by doing what's called a vertical line test. And a vertical line test is exactly what it sounds like. We just draw vertical lines to our graph. And if our vertical line touches our graph at more than one point, it is not a function. So you see here, we're testing this red vertical line saying, okay, is this a function? Well, since it touches our graph here and here, that means that for this one x value, it would generate two different y's. So that means it is not a function. But if we were to draw our graph through all of our points or through our line, and we see that in each of these cases, we only touch our graph at one point, then it is a function. So if we touch our graph at more than one point, it is not, because remember, this is our x value. Let's say that this is 3. Well, if we substitute in for 3, this graph is implying that we have two different answers we can get. We have these two different values, so how do we know which one to use? So if our graph touches or if our vertical line touches our graph at more than one point, it is not a function. All right, and if it doesn't, and it only touches all of our parts of our graph at just one every single time, then it is a function. So we can either interpret the points given to us, or when we're given a graph, we can interpret the graph by a vertical line test. All right, so let's go ahead and go through some examples to determine if things are a function or not. Okay, so for example 1, determine if this is a relation, because we have all points, so it's not a graph. So determine if the given relation is a function. So when we're looking at this, it might be harder for you to look at it when it's given to you in points like this. So maybe you might want to rewrite these as a table if you want. So I'm just going to rewrite -2, -1, 0, 1, 2. So I'm writing all of my x values. Then I'm going to write all my y values. I'm going to use a different color for this. As well, just to differentiate between my x's and my y's. Now, what I need to do is look and see is, do I have any repeating x value? That's what we're looking for. We need to see if x is repeating. So -2, well, there's no other -2 in here, and that only gave me a positive, or it gave me a positive 2 in response. There's not two other y values I can have. When I look at -1, well, there's no other -1 in this relation. So I look and say, okay, when I look at my y value, it just gave me that one value, y value in return. When I look at 0, there's no other 0 in my relation. It gave me 2. So there's not 0. 0 didn't generate two different numbers. 1 generated 0 and 2 generated 0. So yes, this is a function. Even though all of our y's seem to repeat in these different forms where it's just all 2's or all 0's, it's okay that our y's are repeating. It's that our x values can't repeat, because remember, we can have two different buttons on the machine that each gives us a Coke, but we can't have one button that gives us a Coke and chips. So in this case, we're looking to see, does our x value repeat? That's what we're focusing on. If our x value repeats, then we need to see, okay, is it giving us the same y both times, or is it giving us a different y? So our x values can't repeat, our independent can't repeat, but our y values can. All right, so this is a function. Let's go through another example. All right, so this one is also a relation because it's given to us in points and not as a graph. So when we look at this relation, we're going to determine if this is a function. So we see, okay, we know our inputs are x's and our outputs are y, so we're looking at our x. So we have -2, 3 as our 1 point. Okay, that's fine. No other -2 is in this table. So right here, this one's starting to work. We have -1. What is no other -1 in our x value? We see it only generates this one y value in return, so we're still working. We go to 0. Whoa, wait a minute. So I see 0 here and I see 0 here. So I have two zeros now for x. So I have two separate inputs. One 0 gives me a 5 while the other gives me a 6. So since they're generating different numbers, no, this is not a function. And if we were to graph this, we would then have a point at 0, 5 and another point above it at 0, 6, and that would fail our vertical line test. So we can see there that this is generating two different y values for the same x. Therefore, it is not a function. All right, so now these last three I just put together because we can go through these kind of quickly, but these are not graphs. So determine if these are a function. So what we need to do to determine if a graph is a function, especially when it's a line like this, you're not going to be able to write out every single one of those points. So we just need to just interpret the graph. So what we do is when it's points, we're just going to draw a line going through all of our points. And you see here, this one right away and this one right away, I knew I could look at that and draw a vertical line. And when you draw your vertical line, make sure you're using dotted line. If you draw a straight line, you're implying that that's part of the graph. So make sure you're using a dotted line because that's showing that we're adding that to it and it's not really the graph. So when I saw those 2 points directly above each other, I knew I could draw a dotted line going through them and intersecting 2 points with that one dotted line. So that fails the vertical line test. So that means no, this is not a function. For this one, no matter where I draw my vertical lines at, it's never going to intersect my graph at more than 1 point. So yes, this is a function because at no point does that vertical line intersect it at more than one. And here for this circle, every single point except for this one point there that barely touches a circle. Every other point is going, or line is going to intersect our circle at more than 1 point. So this one fails our vertical line test, and no, it is not a function. So it's very easy to determine if something is a function or not when you're given the graph. The points are a little bit harder because sometimes the x values repeat and sometimes the y value repeats, and you have to be able to identify when one is a function versus when one is not. All right, that is it for this first section.